So in our last video, we looked at an example of what a vector was, and we drew it out, and we found that we had a sense up to the right. We found the sense, and we found the magnitude, which we found out was just 5 feet. And that was based on its x and y components. Its x component was 3 feet, and its y component was 4 feet. But we stopped short of finding its direction or its angle. So let's go ahead and find that now. Let me go ahead and redraw the triangle a little bit bigger. And so we got our vector n. Well, vector n. And that's, what, 5 feet? And we have its x components and its y components. Let me go ahead and draw that. We got an n of x, which is just 3 feet. Let me make that look a little bit nicer. N of x equals 3 feet. There we go. And we got our n of y, or our y component, which is 4 feet. The next thing we want to find out is, what is the direction of this vector? Or in other words, what is its angle? So we have theta equals question mark. Okay. Well, if you look at it, we already have everything we need to know. We could use sine if we wanted to. We could say, remember, it's SOHCAHTOA. So let's go ahead and get that back on the page. We put it down. Okay, SOHCAHTOA hasn't changed. Well, we know we can use sine. Of course, we're looking for the angle, so in this case, we'd be looking for the inverse sine. So the sine of the -1 of opposite over hypotenuse. Well, the opposite to our angle is 4, and the hypotenuse is 5. So we just pull out our calculator, and we say the inverse sine, which is above sine, so I hit second sine, and I just say 4 over 5. And we get a direction of 53.1 degrees. So go ahead and pick a good color here. Let's pick the original color. 53.1 degrees. You might say, well, Mr. Anderson, what about cosine? Couldn't I have done that instead? Since I know all three sides, couldn't I have done cosine? So couldn't I have done the inverse of cosine is adjacent over hypotenuse? Well, the adjacent is 3, and the hypotenuse is still 5. Could I have tried that one out? And the answer is, well, yeah. We take the cosine of 3 over 5, and we get the exact same answer. And in reality, we could have done the exact same thing with tangent. Tangent to the -1 equal, or times, not equals. Tangent is opposite over adjacent. Well, the opposite is 4, and the adjacent is 3, so 4 over 3. We type that into our calculator, and we get the exact same thing. We do second inverse tangent, and we say 4 over 3. And yeah, we get the same exact answer. It doesn't really matter which one you use. They all equal the same thing, which is 53.1 degrees. But it's important to note that it's 53.1 degrees off of the x-axis here. It's coming off of that. And so we'll say, and it's actually, if you look, it's coming up, sort of a counterclockwise motion. So we'll say counterclockwise from the positive x-axis. From positive x-axis. And that's important to note, is because what if we were measuring from the y-axis instead? Well, that would give us a completely different angle. And in fact, it'd be whatever 53.1 or 90 minus that is, because it's the other half of 90, because we're making a 90-degree angle over here. So we'd say 90 minus 53.1. And we get 36.9. So this one over here would be 36.9. And if you wrote that answer down, which would technically be correct, 36.9, not 36.6, 0.9 degrees, we would say that's coming clockwise. If you look at sort of coming clockwise in this sort of direction from the positive x-axis. And both of these answers would technically be correct.